Hi, everybody. My name is Okampala. Too loud? No? Good? Okay. I work at NC State. I just moved to computer science department. Before that, I was at the Center for Geospatial Analytics. I'm a senior research scientist and also faculty member. And we have talking today Andrew Potter from the Jacob Solutions, and he was one of our MGIST students a couple of years ago when he started working on this application. And we also have Adem Kurtuvek, who's a research associate at the Center for Geospatial Analytics at NC State. So today we're going to be talking about the tool set that we developed for NCDOT, because they want to be able to do some demographic analysis for the planning process and also permitting process and community studies and community outreach and things like that. So we'll show you the tool sets that we developed. And for this, so there's two of them. And first one, Andrew will talk about that because he was the main developer on that. And then next one, Adam and I will talk about it. So first one is mainly doing a general demographic analysis, being able to compare data at different spatial layers, levels, and many more. And the second one is a more of a dashboard approach that we implemented that we'll talk about briefly. So without further ado, I'll pass it to Andrew and see you back in 10 minutes.
Hey, everyone. Like Okan said, I'm Andrew Potter. I work for Jacob Solutions. I'm a solution architect. And this application we developed a couple years ago, so it's not so fresh on my mind, but we kind of delved back through the old slide deck and pulled it together. So kind of the scenario here is that the NCDOT builds and maintains infrastructure, obviously, right? And as they're building infrastructure, they're seeking to distribute costs and benefits of various projects evenly. And in order to be able to understand what types of people, what communities could be impacting, they need to be able to look at census data quickly. They need to be able to compare different geometries. They need to be able to compare different tables and fields. And so in order to do this, they use the 5-year American Community Survey estimates. And these are just, I'm sure a lot of people in here are familiar with this data, but it's 5-year rolling averages. They're released annually, right? So nice thing about this data is you can see, you can get a snapshot of lots of different information annually. And so we needed to develop an application that enabled users to view this data at various geographic scales. So at state, tract, block group, all these different scales that are available in this data. They need to be able to visualize how the data changes over time. They need to be able to compare this data for selected areas to other areas. So select one census tract, compare it to another census tract. And they also need to be able to compare to higher geometries. So say they select the census tract or block group, they need to be able to compare that to another tract, to the county, to the state. So that's a lot of requirements, right? And so we'll talk a little bit about some of the challenges that went into this and the solution that we ended up developing. So the first thing to know is there's a lot of data. So we grabbed 10 years of data. We didn't really know exactly what they wanted. And so we wanted to build something that was flexible enough to put really all of the tools in their hands so that they could go find the data they wanted and visualize it how they wanted to. But the first issue we have, as I know many of us have experienced, is this idea of data cardinality, right? We have one tract that could be related to lots of different records. And particularly, with spatial data, these polygons are pretty heavy, right? We don't want to copy all of these polygons to every one of our rows in our database because that's going to be a huge database, and Okan would probably not be okay with me putting a 50 gig database on his server or something like that. So obviously, we don't want to go the stacked geometry route, and so we wanted to go with related tables. And that's fine, but if you're going to do some SQL joins with this data, we end up with 22 million rows in the database. That's going to be a lot of SQL, right? So what we ended up doing is we decided to keep these two things separate. We wanted to keep the geometry in feature classes, and so we have block groups, counties, states, tracts, zip codes, and then we have all of the data pretty much as it came out of the census data in non-spatial tables. And so we ended up with 5 feature classes, over 150 non-spatial tables in a file geodatabase. We wrote some Python code, used pandas to parse it and map it to the appropriate fields in non-spatial tables. And we loaded it all up into an enterprise zoo database and published it to the server, as you can see on the right. That probably looks familiar to a lot of people in here. But we didn't write any SQL. So how does this app work? You're thinking, this guy's crazy. There's no way that this app is going to work. Well, what we did is we utilized dynamic map image layer joins. And if you spend a lot of time reading the ArcGIS JavaScript API documentation, as I'm sure many of you do, no, I know, this is actually a really powerful tool. So these dynamic map image layers basically enable you to create sublayers on the fly from any data that you have in a registered data source, right? So what we did is we registered our enterprise geodatabase. The top right there, you see that's that's server manager. So you go and you enable dynamic workspace, and then you can enable the user to join data to non-spatial tables on the fly. And so we don't have to write 200 plus SQL statements to do this. We utilize these dynamic map image layer joins. Now, the flip side of that is you got to write some JavaScript, right? You have to go build the front end. So that puts you out of the realm of the out-of-the-box web app builder or experience builder, whatever it may be. But if you're like me, that's exciting. So we viewed it as an opportunity to go build an app. So here's a little sample. So here's our map image layer, little JavaScript in case you're interested. But you see our data source is a join table. So the left table source, that's the feature class. The right table source is where we enable the user to specify which table, which field they want to visualize. And so you see, that's the only SQL we wrote is in that statement right there. So we end up with a custom JavaScript application where the user can specify the geometry they're interested in, the subject area, the table, which field they want to view, and they can also choose a normalization field so that they can end up with a percentage rather than just a raw count of whatever they're looking to do. And so here's just some examples of the filters. If we have any time, we can do a quick demo at the end, but you can see they can choose a geometry, they can choose a subject area, a table, a field, a year, and all of these things filter dynamically too. So when they choose, poverty to view that subject area, it's going to filter the tables, and then when you choose a table, it filters the fields, so on. And so now we'll just step through some of the capabilities of the app. So we can see here they're looking at a state level view of basically poverty level normalized by population, and then we can, with just a couple clicks, we can go to counties. We can then drill down to census tracts, and then we can get all the way down into block groups. And you'll notice the data isn't always available at every scale. So we have some grayed out areas where the data wasn't available for that particular year. But they can very quickly and easily change the field they want to view, the table they want to view, and the geometry that they want to view with this application. And then they can zoom in a little bit and easily see, looking around Durham, we're looking at poverty normalized by population. It's easy to see where hotspots are in this area for poverty, right? And then they can see how this data changes over time. So 2017, 2018, 2019, they can quickly toggle through their years and see how this data is trending. And then we wanted to enable them to view this data year by year comparisons in a chart, and also to be able to compare to higher geometries. So right here, we can see how the data is changing over time. They click a button, and this is chart.js, goes and queries the previous data for this census tract and plots it all on a chart. They can also choose to compare that to whatever's higher. So if they're at a tract, they compare to county and state, and it's going to pull all the data for whatever they select. And then finally, they can also compare various areas. So they can either draw polygons, they can drop points to compare various geometries that they've drawn to others and plot that data over time. I think that's all I have for this app. So I'll hand it off to Adam, and then if there's any time, we can go through the app a little bit. Okay. And that's at the end, right? So we'll just. I guess I should just pop out of this. Sorry, Adam, you're gonna have to go back. Tell Okan if it crashes. Don't tell me. Yeah, it's in Azure, and who knows how it's gonna do. So we'll just go with census tracts. They can choose a subject area. Oh, how do I do that? Oh, do I need to drag it over?
Yeah, just minimize the. Yeah, and then drag over the other one. Come back to the.
How do I? All right, I'll let you do it.
There you go.
Okay, and we just rebuilt the UI here. So this is using Vue as the framework. So I've been messing with that a little bit. So yeah, we can go down. We can look at poverty. We can choose a table, and so there's like 10 different tables here that are in this subject area. We can choose a field in this table. There are a ton of fields, various demographic groups. I usually just pick poverty level because there's so many in there. And then we can normalize it over another field. So it'll normalize it by the total population. And then we could choose in a year. And so we did this 2 years ago, 3 years ago, so it was 2021. So the most recent data we had was 2019 because the 2020 census results weren't out yet. So this was current data a couple years ago when we did this. And then we can run the query, and it'll build it right there. And so if we wanted to, so that's looking at, census tracts. If we wanted to, we could real quick come in here and switch to counties. And we'll build this join on the fly, right? And it's pretty snappy too, considering how much data is in this database. And so we can quickly view different geographies, geometries. We can look at different fields. We can look at different years. So we can change the field we're visualizing. So this is just using like a class breaks renderer. So we could, that is certainly something you could do. You just specify different breaks. And so this is just breaking and basically, quartiles, right? But we could specify a different type of renderer. There's some really nice tools in the ArcGIS JavaScript API. But like if we wanted to come in here to Winston-Salem, we can get a nice view of the downtown area and where there could be, levels of elevated poverty, right? And then on this version, I don't have the capability to compare to higher geometries just yet. That would be on the older version, but we can just select multiples and it will throw them on the map. And my chart didn't draw for some reason. There we go. And so it labels them dynamically, and then the user can hover over, what they're interested in and see the data as it changes over time. And then you would imagine, in the previous version of the app, you could also, when you go to click your single tract, it would give you the opportunity to compare that to either the county or state level. So that's about it. Sure.
So this application is good for NCDO to be able to DOT to be able to go in and compare various geographic scales, and the data is provided by census at block group level, tract level, zip code level, or county level. But they really wanted to be able to look at a specific block group, like a couple of block groups that they're interested in, and being able to compare that on the fly with the county average. And being able to do that is a big deal without having to go through downloading all these tables and having a JS analyst be able to go in and do the analysis and bring back the result. This way, they can just do that on the fly and understand the general area that they're looking at, and they can use it there for permitting purposes and things like that. So again, we're still rebuilding this application with a slightly newer technology, and that a comparison functionality will be included as soon as well. And then once that's done, we're going to move that onto a staging server. And once it's smooth, then maybe we'll move it onto a production server eventually. So hopefully we won't have to update it again. So the next one that we want to talk about is actually a dashboard. And I'll go back to the presentation for that. Are we doing on time? Okay, that's not too bad. So this part we called it EJ dashboard because that's what the NCDOT personnel wanted to call it, because before this, they were going to the EPA's EJ tool, and they were using that for their own purposes. But that was falling short on some specific categories, and also being able to look at various scales wasn't available, and also North Carolina data, some of it wasn't exactly as they wanted. So we built the data, this dashboard for them. So it's not as complicated as the Insight dashboard that they were showing to you guys in the previous talk, but it is as functional, and it's cleaner if you ask me. So this is the dashboard look like. It's a little bit widened because of the presentation template. So we wanted to be able to have this map and have the data for a specific area that's selected as you selected it. And we wanted to be able to add more block groups to the data and be able to see that specific information for those block groups that is calculated specially for their workflows. So in this case, so let me just talk about the application overlay first. So the left side is for just visualization purposes. So if you click something on here, it updates the map itself. And in each group, we work the transparency. So when you put it together, it adds up to see compound effect of that additional category in that group. But top to bottom, separate groups overlay each other, so you can't see the other groups. So you have to turn off the standard deviation EJ score to be able to see the demographic. But adding each of these on, if that's the only one that's on, then you can actually see the map as you add on those layers. Then the transparency of those allow each other to be able to see on top of each other. We'll see that in a second. So this is the visualization only, and we have some subcategories we're going to talk about in a second, and updates this map. And here on the left is the breakdown of the various information categories. So it's still parallel to this, select versions of these that they really wanted to see as we select. And at the bottom, we have the total population graph in 5-year increments, and also total population graph in 1-year increments. Again, this is before 2020 census was released. We got the data and implemented this dashboard. And looking at this dashboard, one important functionality is generic things like search and base map functionality is pretty generic, so we added those. But we also added a selection that updates the dashboard. So on this slide, we zoomed in this instance Salem, and thanks Adam for making the slides. And looking here, going up to the top level, on the top left, there's a selection tool. So when you select that on the map, it's going to go ahead and update the visualizations at the bottom and on the side. So overall, all these subcategories and the pie charts, as well as the yearly population and 5-yearly population numbers will update when you select a specific area like this. So let's see if we can do that. Okay, here, once we selected this area, all the numbers update based on that selected area, and along with the 5-year and 1-year population averages are updated as well. So next, I would like to talk about these categories, because they're like, some of them are straight from census and some of them came from the we specifically calculated it. And so on this one, you'll see standard deviation is, we wanted to be able to see the EJ score, what they call that, as in the standard deviation and quantile. So we just took basically 100% of the standard deviation below the average, 50% below the average, and 50% above average, and 100% above average, and made four categories for the standard deviation. And quantile is basically the numbers average from 10% to 100% in that scale. And demographics is basically Hispanic, low-income, minority, and over 65. And there's special calculations for that. It's not straight from the census. We calculated some of those specifically. And language assistance shows the areas where it's 50%, more than 50% of the population is English language assistance need. And internet access is basically mobile only or no high-speed internet. And vehicle access is no car versus one car. And then they also wanted to be able to see the areas where there's a lot of rentals, right? And we also have a data table on here. When you select the subgroups of the block groups, you get a breakdown of that selection with all the numbers listed on there. And once you have a selection, actually, you can press these arrow buttons on the left and right of that total population to see the charts, 5-year demographic charts of those various subgroups, like the race-based or age-based subgroups. So these are the race-based ones. So maximizing that chart at the bottom, there's a maximization button on there. When you maximize it, these pop up, or you can use the arrow on the sides to be able to see the minority, Asian, Black, Hispanic, multiracial, and other categories charts in the last 5 years, from 2013 to 2019 data. And this allows NCDOT analysts to be able to look at a specific area when they want to plan for a project there, or there's a project going in, being worked on, and they want to be able to figure out what the impact of that project is going to be on the society and on the local population, and how it might change that in the future. They can go look here and run specific analysis and do their permitting process and paperwork. So this is the language assistance category for this, and as you add the other ones, it would show automatically. And we have the limited access versus mobile, and vehicle access, and rental area, number of rented houses information. Again, the left side is visualization only, and bottom and the side is based on the selection. If you don't select anything, it shows it for all the viewing area. And if you select a one or many block groups, then it will show that what selection, and the data table and population breakdowns, as well as the charts on the right, update based on that. Quick note about using the dashboards. We wrote some R scripts to actually get all these tables out into one table. So when you're using dashboards, you actually have to scale some of your data. So if you're assigning score, like 1 to 3 score onto, let's say, language assistance groups, then you're gonna have to make that, scale that up to like 1 to 100 to fit all the other groups that's in the same group with that, to make it work together so that it grows fast and it works in the specific format. So that was one of the challenges that we found out, that if you want to use dashboards, you actually have to make a big giant table that grows super fast, but it still has to be one giant table to go in there. And sometimes getting all the data into the same scale to be able to display on there can be challenging and not misrepresent some of the data. It makes it challenging. So that's pretty much it. I think I'm out of time as well. So these are the QR codes and the short links here. Go.ncsu.edu/demographic or go.ncsu.edu/EJ will take you to the first application or the second application. And with that, we're going to do a demo. Adam was going to do a demo, but we're out of time. But I'm happy to talk to you after the session if you guys have any questions. So I'm happy to take some questions now and we can discuss further later. Go ahead. Who's developing that? Okay, yeah. So I don't really know the answer to the question. So we built this, and this right now, this is in commenting period as well. So we said, hey, this is ready if you guys want to look at it and give us feedback and see how you guys can use it, and then we can move forward based on that. So we are waiting on them to give us feedback on that and see how it will work alongside. But I'm pretty sure that they still are happy to have some North Carolina specific data that is built exactly for their own workflows. Because every state have different workflows that they need to pull in different types of numbers and do different analysis. So, so this is still will be useful for them even with that tool in place. I've seen some examples of that, and I think it's really cool to have that kind of application. But at this point, we're bound by the data, right? So we would have to pull in neighborhood level data to be able to implement an application that does what you're talking about. And it is kind of hard to come across that kind of neighborhood level data, and so we can build something on top of it. So, and I guess we could purchase it, and if it's available, but I don't even know if that level data is available. It might need to be developed, or we might need to take census block group or block level data and downscale it to get to that, and maybe run some analytics like walking distance to parks, or some demographic breakdown based on some other synthetic data or something like that. That's what I'm thinking. But if you know any of the data sources, please let me know. I'm interested. Yeah. 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 Okay. Any other questions? I think we're out of time here. All right. Thank you very much. Thanks for being here and listening, and see you guys around.